Problem of the day: 5 steps. Must have 5 steps. Um, First step, right? We notify this is a secondary uh, electrophile, alkyl halide. Leaving group's going to leave, right? So we're going to make, of course, Cl minus is kind of just along for the ride here for a long time. Next thing we're going to do is a rearrangement. We're from secondary, and we have, you can see here, the leaving group's on this carbon, but all of a sudden the thing that adds, the solvent that adds, is way over here. So it tells you there's going to be a rearrangement. So it also tells you SN1, 5 steps. We only do rearrangements if it makes something more stable. So we went from a secondary, and if this hydrogen moves, it rearranges. The electrons move, not the hydrogen. The electrons move, and the hydrogen comes with it. So make sure you start your arrow here. We've got a tertiary carbocation. Only way you can make something better than that would be something that's tertiary and allylic or benzoic. And so the ethyl is going to rearrange, step 3. Ethyl instead of methyl, just because that's what I said moved. Ethyl moves. Finally, so tertiary allylic, really stable. Finally, the solvent now is going to add. Remember the OH here, nothing happens to the H. It's the electrons from the oxygen there in the nucleophile to the carbon, that's the carbocation. Now chlorine minus comes back in, deprotonates and takes the H, so the H could have just fallen off. It's fine too for that proton transfer, and that gets you to your final product. SN1 reaction with a couple of rearrangements. Balance those charges.